Hey guys, Miss Watkins here, and welcome back to Unit 2, which is going to include 3 chapters in your AMSCO books. It's going to include Chapter 3, Chapter 4, and Chapter 5. And Unit 2 is all about population and migration. Chapter 3 and 4 are on population, and Chapter 5 is on migration. Take a second and watch this video about human population and migration over time. Human geography tries to explain why people live where they do. It includes the study of 2 distinct but related concepts: population distribution and population density. Population distribution is the pattern of human settlement, the spread of people across the earth. Representing it on a map highlights places that are crowded or sparsely settled or even empty. Population density is the measure of the average population per square mile or kilometer of an area. It measures how crowded a place is, or it can measure specific things, like this map of Ireland, which shows us the proportion of respondents to the Ireland census in 2011 or Northern Ireland census in 2011 who stated they were Catholic. And as you can see, the majority of people in the Republic of Ireland are Catholic, whereas in parts of Northern Ireland, they are not. Take a second and watch this quick video about population density. There are 3 different ways that we look at density. The first is called arithmetic density, which is the total number of objects in an area. So in order to do that, you take the entire population for a region and you divide that by the entire land area for that region. So you see here a map of arithmetic density around the world, and from it we can see that certain Asian and European countries are much more densely populated than the American or African countries. So arithmetic density is used to compare distribution of population in different countries. From this map of Europe, we can see that the most densely populated parts of Europe are Germany, the Netherlands, Belgium, the UK. These areas are much more densely populated than, say, Norway or Sweden. The second type of density we'll look at is called physiological density, and this is the number of persons per unit of area suitable for agriculture. So instead of taking the entire land area, you're only going to divide the population by the amount of arable land. This is going to show you, does this country have enough arable land to support its population? This number could mean a country has difficulty growing enough food. The third type of density is known as agricultural density, and this is the number of farmers per unit of area of farmland. So now, instead of looking at the entire population, we're just looking at the number of farmers divided by the number of arable land. And just looking at this number can tell you how developed a country is or not. A highly developed country like the United States is going to have a very low agricultural density, meaning that we don't have very many farmers and we have a lot of arable land because our farmers have technology. Whereas less developed countries are going to have very high agricultural densities where they have a lot of farmers per arable land because they're working by hand, so there's a lot more people involved. So this may mean a country has inefficient agriculture. Take a second and watch these next 2 short videos. Understanding both population distribution and density helps people make important decisions on issues such as where to set boundaries of electoral districts or where to develop new housing. These are among the many issues influenced by the number, distribution, and density of current and projected population. Even though there's over 7 billion of us, humans actually live on a very small percentage of the planet. You can see from this map there's really 4 major clusters where most humans on this planet live. That's in East Asia, South Asia, Europe, and Eastern North America. Starting around 1800, we see a rapid population explosion. This is known as exponential growth. And the world contains 7 times as many people as it did 2 centuries ago. Right around this time of when we start to see this exponential growth is what's known as the Industrial Revolution. And we're going to learn a lot more about the Industrial Revolution and its effect on population. The Black Death was a devastating global epidemic of bubonic plague that struck Europe and Asia in the mid-1300s, and it actually killed an estimated 1/3 of Europe's entire population. The plague arrived in Europe in October of 1347 when 12 ships from the Black Sea docked at the Sicilian port of Messina. Most sailors aboard the ship were dead, and those still alive were gravely ill and covered in black boils that oozed blood and pus. Sicilian authorities hastily ordered the fleet of death ships out of the harbor, but it was too late. The Black Death was terrifyingly, indiscriminately contagious. The mere touching of the clothes, wrote Botticello, appeared to itself to communicate the malady to the toucher. Today, scientists understand that the Black Death, known as the plague, is actually spread by a type of bacteria. And today, because of modern medicines like antibiotics, the Black Death is not a wide-spreading pandemic or epidemic like it used to be. The type of bacteria that causes the Black Death, though, travels from person to person through respiratory droplets or through the air, as well as through the bite of infected fleas and rats. Not long after it struck Messina, the Black Death spread to the port of Marseille in France and the port of Tunis in North Africa. Then it reached Rome and Florence, 2 cities at the center of an elaborate web of trade networks, and there was no stopping it from there. In a panic, healthy people did all they could to avoid the sick. Doctors refused to see patients. Priests refused to administer last rites, which is a big part of the Catholic religion. Shopkeepers closed their stores. Many people fled the cities for the countryside, but even there they could not escape the disease. It affected cows, sheep, goats, pigs, and chickens as well as people. It's estimated the Black Death killed 30 to 60% of Europe's total population. The Black Death epidemic had run its course by the early 1350s, but the plague reappeared every few generations for centuries, and still appears today, but again, because of modern medicine, specifically antibiotics, we're able to fight the Black Plague. So one of the major reasons why we see population explode around 1800 and the Industrial Revolution is because this is when we start to see huge advances in medical technology. From antibiotics to vaccines, we see a lot less death happen after 1800. So while population density has increased significantly, population distribution has not. We still live in the same few places that we did 2,000 years ago. And again, those 3 major areas being East Asia, South Asia, and Europe. The vast majority of population growth has been in areas already settled. For example, Eastern China was one of the most populated parts of the world in 1800, and it still is today. And the reason why these places are so densely populated is because these are the best places for agriculture in the entire world. This is the best farmland in the world, so it can actually support having a lot of people. With an ever-growing population density, we see humans invent new ways to live in larger numbers, including different types of buildings. Take a second and watch this video about some of the world's previously most densely populated places. Why have people chosen to live in such crowded places? Bangladesh is one of the most densely populated places on Earth. Bangladesh, being one of the most densely populated places on Earth, is because of its land size compared to population. China is the most populated country on Earth, but it is not the most densely populated, and that's because China has a lot of land area. Bangladesh, however, is a very small country with a large population, which means there's a lot of people per land area. Where people live. People want to live in places where they can survive with relative ease and comfort, places where they can raise or obtain food and live in moderate climates. Even when there was only 1 billion compared to the 7 billion we have today, they were dispersed throughout such desirable lands as they still are today. As population increased, the amount of suitable land stayed about the same, so people chose to live in greater densities on that same land. Physical factors influencing population distribution. Survival for the earliest humans depended on food, water, and shelter. Thus, these hunter-gatherers settled where those features were most readily available. Similarly, people today have the same basic need, which helps explain why the population distribution has remained so similar over time. Most people live in what is known as the mid-latitudes, the regions between 30 degrees north and 60 degrees north, and between 30 degrees south and 60 degrees south. That's because these places, in terms of latitude, are the most advantageous for climate in terms of agriculture. These areas have more moderate climates and better soils than regions at higher and lower latitudes do. We don't live in large numbers in the low latitudes, except for a few exceptions like Indonesia, because tropical climates are not good for human agriculture. We don't live in the polar latitudes or the high latitudes because it's too cold for our human agriculture. This pattern is particularly noticeable in the northern hemisphere because it includes so much more land than the southern hemisphere. So the reason why most humans live in the northern hemisphere is because there's not much of that land in the mid-latitudes in the southern hemisphere. Most people live in low-lying areas rather than high in the mountains, again because it's more advantageous for human agriculture. Low-lying areas typically have better soils for raising crops than do upland or high-altitude areas. In addition, these areas are often close to oceans, which facilitate transportation, provide a source of food, and have moderate effect on temperature. Most people live near freshwater lakes or rivers. The Nile River Delta in northern Africa is one of the most densely populated regions in the world. The freshwater biome is made up of all the inland water sources with a salinity of less than 1%, meaning less than 1% of salt. There are several reasons why people live near fresh water. We need fresh water to drink. We also can use it for irrigation for our crops. We can use it for transportation and to provide us food, and all of the fisheries and things like that are known as aquaculture. Water also has a moderating effect on temperature. People also have a desire for natural resources, such as forest products and minerals, so we are also going to live near those. Human factors influencing population distribution. In places where humans first settled, people did so because a place's natural features attracted them. However, then the people themselves became an attraction. With more people comes more people. Newcomers moved in for safety or to find a job or to be with friends or relatives. Where people decide to place transportation networks also has a significant impact on population distribution. Early in U.S. westward expansion, we see towns pop up around the railroads. People prefer to live close to trade routes, that way they can easily access goods. Roads, train lines, and rivers often produce a linear settlement pattern in which houses and communities stretch out in a line. We see the settlement pattern here along the Mississippi River from Minnesota all the way to New Orleans. Political decisions sometimes bring clusters of populations to isolated locations where physical attributes would not normally attract settlement. An example of this is in Alert, Canada, which is in the Northwest Territory, a very isolated region where the Canadian government has actually paid people to specifically move there. From this map, you can see where Alert, Canada is located, and it's in the most northern part, basically as close to the North Pole as you can get in Canada. Canada is not the only one who pays its citizens to live in this region. Russia does this as well, and part of the reason is because they are trying to establish control as the Arctic Ocean unfreezes. Here we see the Canadian military base in Alert, which is the most northerly community in the world. The original reason for the settlement of Alert, Canada was because of where it was situated in what was then near the Soviet Union. It allowed the Canadian military to monitor possibly hostile Soviet military activities. Cultural situations often result in new distributions of particular groups of people. Religious groups such as the Amish and the Mormons resettled thousands of miles from their homelands to protect themselves and preserve their beliefs. The Amish originate in Europe, specifically in Germany and in Switzerland, but they moved to North America because they were facing religious persecution. The Mormons actually started in North America in New York, but they moved to Utah to escape religious persecution. The Amish purposely moved to Pennsylvania because of the religious freedom that that specific colony offered, and that's where the Amish still mainly live today. The Mormon Trail was the actual walk that these Mormon pioneers did from New York to Utah, specifically the area around Salt Lake City. Scale of analysis and physical factors. The basic principle that people want to live on the most desirable land applies at any scale or level of analysis by size. On the global scale, high altitude areas such as in the Himalayas and the Rockies have cold climates, so such places usually have limited populations. Climate also explains population distribution of a large state such as California, where climate varies greatly within the state. On a smaller scale, such as a city, the spatial climate variation is usually too small to affect settlement. However, elevation is sometimes important at the city level. People might prefer to live at higher elevations in a city because these spots offer safety from floods and inspiring views of the landscape. Scale of analysis and human factors. Polluted air is a health hazard, yet it may signal industrialization, economic development, and employment opportunities. On a global or national scale, millions of people are often attracted to areas of such economic opportunities, and they might willingly move to the polluted area. Take a second and watch this short video clip. At a city scale, few people intentionally choose to settle near a pollution source unless they have to live there because of lower property values. Governments also have a significant influence on population distribution at different scales. A national government might increase the population of an area by building a new military base. A state might reduce population in an area by creating a state park. These lands would then hinder future development. A city government might affect population distribution by allowing high-rise apartment buildings in some areas, which would increase the density there. Reserving other areas for single-family homes, which would mean less densely populated. Factors influencing a city's population distribution, such as elevation, proximity to desirable land use, and land use laws, commonly result in a population distribution that reflects social stratification. Typically, we're going to see the wealthy people live on the most desirable land, and the poor people live on the least desirable land. Social stratification is the hierarchical division of people into groups based on factors such as economic status, power, ethnicity, or religion. Population density. Population density measures the average number of people in an area. Again, it's called arithmetic density, and you find it by calculating the area's total population divided by its size. It's usually expressed in the number of people per square mile or square kilometer. And again, demographers study those three different types of population density, which include arithmetic density, physiological density, and agricultural density. Demography is the study of statistics such as births, deaths, income, or the incidence of disease, which illustrate the changing structure of human populations. The most commonly used population density is the arithmetic population density, which again is calculated by dividing a region's population by its total land area. Here we see that just because it may be the largest city like Tokyo doesn't necessarily mean that it's the most densely populated city. We see that places like Calcutta or Mexico City or Sao Paulo are actually more densely populated than Tokyo. In July of 2015, the United States had a population of approximately 321 million plus in a total area of about 3.8 million square miles. So the arithmetic density then of the US was approximately 83.6 people per square mile. The problem with looking at arithmetic density for large areas is it's not truly accurate. We don't really live 83 people per square mile. What's true is some places have much larger population densities and some places have much less. For example, DeQuincy, Louisiana has a population of 3,235 people. The land area is only 3.18 square miles, which means their arithmetic density is 1,017 people per square mile, which is very dense. So while arithmetic density tells us the total number of people by land area, the problem is it tells us very little about population distribution, where people actually live within that area. Population density is simply an average number of people overall in an area. It does not indicate where in the area they actually live. The uniform pattern is common in areas where each person or household lives on a large plot of land. At different scales and with different numbers, this basic pattern appears in many suburbs and many farming and ranching areas. The clumped is a common pattern where people live near a central feature, such as a church or a school. So within those three general patterns of clumping, uniform distribution, and random distribution, most species live in clumps or groups. We can see that clumping here on the map of population of the US. We live clumped together in certain areas, which would be our major cities, and then relatively far apart and sparsely populated in other areas. Another measure we said is physiological population density. This again is calculated by dividing population by the amount of arable land, which is farmland. Arable land is land suitable for growing crops. Physiological density. What doesn't arithmetic density tell us about land a population occupies? Population divided by just arable land instead of total land is what physiological density shows us. So for example, the US versus Egypt. For the US, we see there's 172 persons per square of arable land, whereas in Egypt, there's 2,580 persons per square kilometer. So what does this mean? It demonstrates that crops grown on a hectare of land in Egypt must feed far more people than on a hectare in the US. So the bigger the physiological density, the bigger the pressure people place on the land to produce food. So over in Egypt, for example, we see such a high physiological density because most of Egypt is completely non-arable because it's Sahara Desert. The only arable land in Egypt is along the Mediterranean and the Nile River. Egypt's high physiological density suggests a need for greater crop yields or for other food sources. Watch this short video about agriculture in Egypt. The physiological population density is a much more useful measure than the arithmetic density when trying to determine a region's carrying capacity. Carrying capacity is the amount of population a piece of land can support without significant environmental deterioration. As human population continues to grow exponentially, at some point, Earth, like all ecosystems, will reach a carrying capacity if we don't slow down our population. A country with a high physiological density indicates that it needs high crop yields, but higher yields are not always possible. So many regions who can't grow enough food to support their populations have to rely on imported food. Japan is one of those places. Japan is a small series of islands with a very large population, and because it's islands and mainly mountainous islands, there's not very much arable land here. Egypt and Japan both have physiological densities greater than 8,000 people per square mile of arable land. In both countries, growing enough food to feed everyone is not practical with current technology. Both supplement crops through the fishing industry and with imported food. However, paying for imported food is much easier for Japan because they are a highly developed country than for Egypt, which is a less developed country. Countries with high physiological densities face extra challenges feeding their populations. From this chart, we can see that Egypt is going to have a much harder time feeding its population than India or even Canada, because both India and Canada have a lot more arable food per population. The third type of population density is agricultural population density. And again, the big difference here is this is now, instead of looking at total people, it's just looking at farmers. So farmers divided by arable land. This again is a great measure of development. We see in less developed places, you're going to have a lot more farmers per arable land than in highly developed countries. That's because in highly developed countries, we don't need a lot of farmers because our farmers have the technology that makes it possible for them to farm large areas with a lot less people. So this value gives an indication of the efficiency of a region's farmers. Developed countries have lower agricultural densities because farmers have resources to use technology to produce large quantities of food with very few workers. The agricultural densities in less developed countries are higher because farmers often cannot afford modern technology, so they depend more upon labor. So remember, arithmetic density, total number of people in an area, population divided by total land area. Physiological density is the total people supported by unit area of arable land. And this again provides insights into the relationship between the size of a population and the availability of resources in the region. Agricultural density is the ratio of the number of farmers to the amount of arable land. So make sure that you guys definitely know all of these different types of densities and what they tell us. Population density and time. Density also varies by time of year. Warm weather states such as Arizona and Florida become more dense each winter as snowbirds, which are people from northern states, flee the cold weather. Time of day also influences population density. About 1.5 million people reside in New York City's borough of Manhattan. But each weekday when commuters enter the city to go to work, the population rises to about 3 million. Such variation in population is a challenge for Manhattan, which provides water, sewer, fire protection, and other services for 3 million people, even though most return home elsewhere. Economic, political, and social processes. Most economic decisions are based at least partly on population distribution and density. Businesses are more likely to earn profits when they are near a large customer base. For manufacturing plants, being close to a large labor force is important. Towns and cities have large concentrated populations that provide customers and workers for businesses, so that's where most businesses are going to locate. Facilities such as schools, police stations, fire stations, social assistant offices, and hospitals are usually positioned close to concentrations of population. Environment and natural resources. Whether a region experiences overpopulation, which is having more people than it can support, is partially dependent on its population distribution and density. Take a second and watch these two video clips. Another factor in the region's carrying capacity, the number of people it can support without damaging the environment. The higher the population density, usually the greater it will be a strain on the environment. High population density can result in environmental problems such as pollution or depletion of resources. Because of factors such as sewage and industrial waste, many lakes and rivers no longer provide drinkable water. In some areas, water must be purified or piped in from hundreds of miles away. Population composition. Identifying the composition of a region's population is crucial to understanding that region's past, present, and future. Population composition involves demographic characteristics such as language, religion, ethnicity, age, and sex. Here we see a pie chart of the U.S. population by race in 2015. Ethnicity. Ethnicity is different than race. Race is just your skin color, but ethnicity has to do with your culture tied to a particular location. So while on the outside it might look like to us as foreigners, people in Kenya look similar, in fact, there's hundreds of different ethnic groups in Kenya. The Zulu are one of the largest ethnic groups in sub-Saharan Africa. Kenya's smallest ethnic group is known as El Molo. The Burats, numbering approximately 500,000, are the largest indigenous group in Siberia, which is part of Russia. Frequently, members of a particular ethnic group cluster in particular regions. Here we see a very basic map of different ethnic groups. Group members might choose to live close to each other for cultural reasons. In Vietnam, the Tay ethnic group, with more than 1.6 million population, is the second largest ethnic group in Vietnam. They have their own cultural practices that are different than the larger Vietnamese. In Pakistan, Punjabis make up about 45% of Pakistan's population, making them one of the largest ethnic groups in Pakistan. But country boundaries don't always follow ethnic boundaries, and so Punjabis can be found in both Pakistan and in neighboring India. Clustering together is often true of immigrants or some religious groups. Many cities have neighborhoods named for these ethnic clusters, such as Little Italy or Chinatown in New York City. Some ethnic clusters have special needs requiring special funding, such as funds to help preserve distinctive architecture or to provide English language training. Age and sex. There may also be distribution patterns related to age and sex. Some regions of a country have a younger or older average population than others. Take a look at Florida. You will see that compared to the rest of the South, Florida has a very high median age. That's because a lot of older people retire to Florida. In 2015, Utah had the youngest average age in the United States at only 30.7 years. And this also has to do with culture because of the Mormon religion, which believes in having a lot of children. With that higher birth rate, you're going to have a lower median age. So because of that, officials in Utah have a higher percentage of school-age children to provide for. While the oldest average age state is Maine at 42.7 years. Officials in Maine, as opposed to Utah, are going to be more concerned with the need for services for seniors. Differences in the gender balance can result from wars, migrations, and government policies. The combination of China's one-child policy and social customs has resulted in a gender imbalance so great that for tens of millions of men, finding a marriage partner is soon to be next to impossible. Current estimates say that Chinese men this year will outnumber women by 15 million and by 30 million in 2050. At the level of entire communities, mining towns and military training bases often have significantly more males than females. Within a city, a gender imbalance might appear if one neighborhood has a post-secondary institution offering courses that tend to attract mostly students of one gender. For example, Agnes Scott College for Women in Decatur, Alabama is going to cause the city of Decatur, Alabama to have a much higher female population. For every 100 females aged 18 and over, there's only 89.5 males. Population pyramids. Take a second and watch this video clip about population pyramids. One of the most useful tools to study population is the age-sex composition graph, which is commonly called a population pyramid. Population pyramids are graphics that show information about the age and gender of people on a specific scale. It can also give evidence of past events such as natural disasters, wars, political changes, and epidemics. Reading a population pyramid. The vertical axis shows age groups, which are known as cohorts. They are often listed in the middle, but are sometimes shown on the left or right side. Pyramids typically show the male population on the left and the female population on the right. The values on the horizontal axis may be percentages or absolute numbers of males and females. Pyramids are most commonly constructed at a country scale, but they can also be constructed for cities, states, or multi-country regions. Here we see one for the City of London. Here we see the country of Sudan in 1995. So what is the first step in interpreting a population pyramid? First, examine the title and the type of data presented. Who are being measured? The cohorts can be arranged by decades or by single years. We always see youngest at the bottom, oldest at the top. Take a second and watch this video. Determining population trends. If a population pyramid has a wide base and tapers upwards like this one, the region's population is growing. We can see that from the shape because each new generation is getting larger and larger and larger. That's represented by an expansive population pyramid. This type of population pyramid are typically representative of developing nations whose populations often have high fertility rates and lower than average life expectancies. So the places where we see the fastest growing populations are going to have that shape population pyramid. A stationary population pyramid describes populations that are not growing. We can see from this shape each new generation is pretty much the same size, which means population is stable. It's not growing or shrinking. They are characterized by their rectangular shape, displaying somewhat equal percentages across age cohorts that taper off towards the top, because what's always going to happen is you're going to have older people start to die. These pyramids are often characteristic of developed nations where birth rates are low and overall quality of life is high. Common patterns. The Niger population pyramid is nearly symmetrical or balanced left to right, indicating there's a balance of males and females. But again, a very fast growing population as we see each new generation getting significantly larger than the previous. Another notable trait on Niger's pyramid is that the changes in the size of the bars from one cohort to the next are gradual. Assuming there's been no circumstances such as war, natural disaster, epidemics, or government interference, a population will be symmetrical and show gradual change between cohorts. Although this tool is based only on age and gender data, it can provide information on birth rates, death rates, how long people live on average, and economic development. Take a second and look at what these different things about the United Kingdom's pyramid can tell us. So there's three main types of pyramids. We see the truly pyramid shape, which shows rapid growth. We see more a rectangular shape, which shows a slow to no growth. And then we also see an inverted pyramid, which can indicate negative growth. We can also see the impact of war on population pyramids. The clearest effect of war on population is that people are killed. Often, half or more of deaths in wartime are civilians, and the death affects people of all ages. However, the loss of fighting-age people, traditionally males between the ages of 18 and 40, is usually the most noticeable. During war, men and women are often separated. Even if they remain together, they may decide to delay a family until the war ends. So not only can war cause death, but it can also cause there to be fewer births. The bars of the pyramid representing children born during the conflict are often significantly shorter than the bars immediately above or below them. This slowdown of births is called a birth deficit. Baby booms, busts, and echoes. Once hostility ends and peace continues, the birth rate often spikes, an increase known as a baby boom. After World War II, the United States saw its largest ever baby boom, which lasted from 1946 to 1965. And that's why today we call the people who were born during this time period baby boomers. Baby booms are usually associated with the end of a war, but booms also can occur for other reasons, such as times of economic abundance. Once a boom ends, births are lower for a number of years. This is known as a baby bust, which continues until the boomers reach childbearing age. With a high number of boomers in the population having children, there can be a significant increase in births that show up as a bulge on the pyramid. Since this increase reflects an earlier baby boom, it's called an echo boom. And an example of this would be the millennial generation, whose parents are baby boomers. So millennials are an example of this echo boom, this time period from the 1980s to the late 1990s where baby boomers were having children. As of 2015, children in high school were the last of the echo cohorts, and their parents were the last baby boomers. Here we see the different cohorts or generations all represented in this population pyramid. At the very top, we see the parents of the baby boomers. Then we see World War II. Then we see the baby boomer generation. After the baby boomers, we see the baby busters, which are known as Generation X. Then the children of baby boomers, which are known as the millennials. And then y'all, which is the youngest generation, which is known as Generation Z. Migration and other anomalies. Many factors can affect a population pyramid. An asymmetrical pyramid, like you see here, is one with significant differences between cohorts, suggesting that something notable happened in the population. This figure shows the population of the United Arab Emirates at the end of 2016. And as you can see, there is a whole lot more males around 18 to 40 in the UAE than females. Can you try to take a guess at what might be the reason for this? You will need to try to be able to come up with types of answers for this type of pyramid. So you need to think about historic events or factors that can cause these types of irregularities. Take a look at the next few pictures of the UAE to try to come up with your answer. The correct answer for why the United Arab Emirates' population pyramid looks this way is because of guest workers. The UAE has an imbalance of men to women as a result of the country's high dependence on foreign male labor, especially in the construction industries. All of those beautiful new buildings are being built by laborers from other countries, mainly South Asian countries like India and Pakistan. There's other reasons why you may see an anomaly in a population pyramid. If you see longer bars for people ages 18 to 25, it could be because a small city includes a large university and a shortage of school funding causes families to move away when they have children. Longer bars for people ages 25 to 50 than for children can show us other things. It can show us an economic crisis, which caused people to decide to have fewer children. It also can show us a government policy to slow down population growth, which discourages births. It could also be because an epidemic caused many infants to die. We see that in China with the implementation of the one-child policy. We also saw it in India, where Indian state governments have been using things to try and slow births. One way they've done this is by paying couples to wait to have babies. In some states, they offer newlyweds cash to wait 2 years to have their first child because they know that the later that women start having children, the fewer children they will have. Another example of a country that has these types of anti-natalist population policies is Uzbekistan, which is located here in Central Asia. Here, the government has instituted a policy of forced sterilization of women after their second child. Doctors are given a quota of sterilizations they have to perform, and they do them without even telling their patients. One reason we could see a population pyramid that has longer bars for people over the age of 65 is if it's a community in a warm climate that attracts retirees, or a place that has a lack of jobs which causes young people to move away. If we see the anomaly of longer bars for males than females, it can be because of things like an oil boom or construction jobs that attract people for jobs that are traditionally done by men, like we saw with the UAE. Dependency ratio. Population pyramid data is frequently used to estimate the dependency ratio, a value comparing the working to non-working parts of a population. Demographers consider people ages 15 to 64 the potential workforce, the group expected to be the society's labor force. Everyone else, people under 15 or over 64, are the dependent population because they are considered too young or too old to work full-time. So as a society, you really want the bulk of your population to be in that working age group so that you're not having too many dependents for the working age group. Dividing the potential workforce by the dependent population results in the dependency ratio. Population pyramids, aka population diagrams, population structures, age-sex diagrams, age-sex structures, or age-sex pyramids, we again can see population is divided into these age groups or cohorts, making the dependency ratio fairly easy to see if we just look at those under the age of 15 and over the age of 64. Imagine a big city in the United States and a small village in Ethiopia. What are some differences between these two locations? Some differences might include climate, population size, culture, and diet. The economies of these two countries are one major characteristic that set them apart. The United States is considered a highly developed country, which is the general category for countries that are highly industrialized and have high per capita income levels. Although highly developed and developing countries are often compared based on economy, they also vary a great deal in population characteristics. Some of the most commonly analyzed population characteristics include infant mortality rate, total fertility rate, replacement level fertility, and age structure. Unfortunately, not all children that are born will survive, and the rate of survival can vary a great deal by the type of country. Infant mortality rate is the term used to describe the percentage of infants that die before the age of 1 year. On average, developing countries have an infant mortality rate that is 18 times higher than the rate of developed countries. The most developed countries have an infant mortality rate less than 1%, while the least developed countries have an average infant mortality rate of around 10%. These differences in infant mortality rate are shocking, and the high rates are due mainly to limited access to medical care, poor sanitation, and increased prevalence of diseases. Poorer countries have higher infant mortality rates and child mortality, sometimes because there's more violence and warfare and also inadequate nutrition and health care. They also have high rates of maternal death, which would be the mother, in childbirth because of plagues and famines and invasions, etc. As a result, the age pyramid is pyramid shape. Whereas in the most developed industrial countries, there are very few childhood deaths, great healthcare and nutrition, and nearly everyone makes it to the elderly years. The demographic shape isn't quite an inverted pyramid, but more like a rectangle standing on its end. So the highly developed countries many times look like this more rectangular shape than an actual pyramid. However, if we look at a different scale and we look at different cities in the US, we can see all different types of population pyramids. So again, the three kind of basic shapes for population pyramids. We see expansive population pyramids, or the Christmas tree pyramid, are used to describe populations that are young and growing. Stationary or near stationary population pyramids are also called the box or rectangle and are used to describe populations that are no longer growing. They are characterized by their rectangular shape, displaying somewhat equal percentages across age cohorts that taper off towards the top. Constricted population pyramids, or inverted pyramids, are used to describe populations that are elderly and shrinking. Constrictive pyramids can often look like coffee cups or beehives. Here we see an interesting look at the country of Namibia, which is in sub-Saharan Africa. In the green, you will see the rural population. In the red, we see the urban population. And from this, you should be able to see that the urban population more reflects a developed country, where the people are having much fewer children, whereas the rural population is the population that's causing the country's growth. So people are having a lot more children. Think to yourselves, why do you think people who live out in the rural or the country would have many more children than people who live in the city? That concludes Chapter 3's notes. In Chapter 4, we're going to learn more about population pyramids and what is known as the demographic transition model. So take a second and watch this quick video to preview what we're going to learn next.